Hello, welcome to this video. In this video, I will walk you through how to build an event-driven microservice architecture using the ride-hailing application as a real-world example. I will run the application end-to-end, and then I'll show you the high-level architecture and the event flows, and we'll take a look at the code as well. So let's see the application in action. All right, so let's get into the demo. So I will have to sign out, and then sign in again and start the process again because I restarted my Docker. So you can see here, I restarted Docker. And so I'll have to sign out and then sign in again so I can have new user IDs and everything to run the application fully. And also, I'm running the Rider application, the Rider part of the application on Chrome browser. This is the Chrome browser. And then this is the driver application. I'm running it in Firefox, Mozilla. So I can just have the both of them in those separate browsers and then you can see the flow. So first, let me sign out from here. So sign out on the user account, on the Rider account. So I'll sign in again quickly. I already have email here. Sign in quickly. And continue. All right, onboarding. Right, Rider. All right, finish. So now let me resubscribe to browser notifications because we have a new user ID now. So let me resubscribe. All right, so great, that's working. So let's handle authentication for the driver. So driver, I think I already have an account here. So driver. All right, so driver, let's present the information for the driver. Driver account, finish. All right, great. So we have a driver now. So let's do the same thing and subscribe and then subscribe to browser event. So we subscribe. So let's add a vehicle. So let's add Ford Explorer here, 2025. In gray, yeah. Let's add a vehicle. All right, great. So you can see the notification came up. New vehicle created. So let's go. Okay, before I leave the driver page, let's go online so that we'll be able to find this driver, this vehicle, and then assign a request to the driver. So you can see here the map. I'm using Mapbox for rendering the map and all the location related things that I will be doing, like the distance, the routing, the just basically distance, the time, and everything, all location related stuff. I'm just using Mapbox APIs. So yeah, so I've set the default location to France, Eiffel Tower, and then all my query for location is going to be constrained to France, basically. So that's what I did. I just set it to France. So let's see, we're in Paris. Let's see Paris. So that's the pickup location that I've set. Let's set the destination to, let's see this. So here's our destination. There's the pickup. So let's confirm the route. So yeah, that's the route. So it's about 5.56 kilometers and about 19.6 minutes from the pickup to this destination. So I'm going to, okay, so another thing I'm doing here, so I have a constant. So I set my base fare constant to be 10 per kilometer. So you just multiplied the distance by the base fare constant, which is 10. So it just gave me 55 euro 60 cents. So yeah, ideally that's like an estimated cost, right? But ideally you have to also factor in other, in the real world application, right? You have to factor in other things to calculate the cost. All right, so I'll click on book right now, and then great, you can see ride assigned. So this is notification coming from the Mozilla browser. Then this is our own notification for this particular Chrome browser that the rider is on. First of all, ride created, notification came in, and then driver assigned notification came in, and then this one went to the driver that, hey, ride has been assigned to you. John has requested a ride. So let's see. Yeah, you can see on the driver end we have the ride assigned and the amount and everything there. So let me close this. So I'm going to just, let's say we've completed the ride here, and I want to complete the ride. So on the driver end, I just click on complete, and then it says ride completed. So invoice created. So this notification is coming from here, the rider part, and then this is coming from this is for the driver part. So the invoice is created, 55 euros, 55 euros, awaiting payment here. So let me close this. And so let me click on pay. So payment successful, payment received. So yeah, the ride is cleared. And so everything was successful. So that's just the end to end. So now let's take a look at the high level architecture and also the event flows of how these events and all these notifications and everything that is happening within the system, how it's happening. All right, let's talk about the high level architecture and the event flow. But before we talk about the architecture, if you want to get browser notifications to show up for the application, if you're running it locally and you want to get browser notifications to show up, ensure you have in your browser settings, you've set permissions to allow notification, and also in your system, right? Your system allows notifications, because I had an issue when I was trying to get notification to work when I was putting the application together for this demo. So just be mindful of that. So here's the high-level architecture diagram. As you can see, the application is broken up into 5 microservices. And you can see that it's a polyglot application as well. So I have different languages, different technologies being used for each of the services. So in notification service, I'm using Nest.js, which is the Java Node.js framework. So this is running Nest.js, this is running the same Nest.js, this is the same Nest.js. But in the vehicle service, I'm using .NET. And then in the user service, I'm using Fast API Python. Right, so I'm using different technologies here, but they are still, the application is still able to, work. Like the application still works even with the different technologies that I'm using. And the reason for that is because I'm using an event broker. So, for example, the Python, the Fast API in Python has its own implementation for Kafka. So you can use the Python Kafka library to publish to a Kafka topic, and then use the C# .NET Kafka library to consume and publish, use the JavaScript version of the Kafka library to publish and consume events, right? So it's just, as long as the technology has a Kafka implementation, because I'm using Kafka as my event broker, you can use it. So that's the idea here. So it's polyglot, different technologies, but they are still able to work together. So the setup is I'm using Docker Compose to define a network. So I have a network, and within that network, only the services that are within that network can communicate. Like the network doesn't allow requests from outside. Like you can access any of the services from outside. So the traffic is only internal to the services within the network. Now, the only container or service that has access to traffic from outside is the API gateway. Now, the API gateway has so when I send a request from the Nest.js application, right? So when you sign in, I get your token. I get a JWT token from mode 0. And then every subsequent request that you send to the backend, to the architect, to the setup, right? Every request that you send, I attach that token that we got from mode 0 to every request. Now, when the request comes in, our API gateway, so for my API gateway, I'm using Kong. So in Kong, you can set a configuration for how you want the routing, like how you, if a request is coming in to a particular route in Kong, you can set the configuration so Kong knows to map that route to the right microservice. So I'm doing all that in the configuration in the API gateway. So I have the route configurations, and then I also have some plugins. So Kong has these plugins that you can use. So they are like, so you think of like middleware, right? So they're like middleware between that just kicks in and validates the request before it can continue into the application. So with Kong, for this particular setup, I'm using 3 Kong plugins. I'm using Cause, right, to like whitelist a domain or blacklist a domain, like domains that I don't want to access the application. I can just blacklist them there, and once a request comes in from them, Kong will just kick them out, deny access. And then I have JWT token. So because I'm getting JWT token from mode 0 in Kong, I have a JWT token plugin to validate that token. So all your requests must come with that BRR token. So I check in Kong if it's valid. It's valid. I allow you go in. And then I have another plugin for rate limiting. So that just prevents your unnecessary calls and just prevents like a denial of service kind of attack on our system. Right, so that's the API gateway. Now the event broker, I'm using Redpanda. So Redpanda is a lightweight drop-in replacement for Kafka. So ideally, Redpanda also just uses the Kafka protocol. So it still does publishing to topics and consuming from topics and subscribing to topics and all that. So let's talk about events, right? So if we, let me use the user created event. Now, for user created event, if I, like on the onboarding page, when you send user information that you captured from the onboarding page, right? When you send that post request, the first thing is it hits our API gateway, and then those plugins kick in. Then we check that the JWT token and everything, that the request is valid. And then once our API gateway has validated the token that everything is good, then the request goes in and comes to our user microservice. Now in the user microservice, you can see each of the microservice has its own database, right? So I'm using Postgres for all of them. So in the user microservice, which is running a fast, I'm using fast API, and I'm connected to a Postgres database. Then I get the request, create a user in the Postgres database, and then publish the user created event to the Kafka topic. So I have a user Kafka topic, so I publish to that user topic. Now, the user microservice is essentially just a publisher, right? It doesn't consume any event. But these other ones, they publish and they consume. This publishes and consumes, this publishes and consumes as well. So notification is just a consumer. So from the user service, I publish the user created event, and then vehicle microservice subscribes to the user topic, and then it gets that event, and then with the payload that I sent with the event on the vehicle microservice, I check if the account property of the user payload, right? If the account property is driver, because I want to be able to, in the vehicle microservice, I want to be able to map a driver to a vehicle. So I want to be able to map a vehicle to a driver, essentially. So I also want to keep a snapshot of user information. So I don't want to have to make an API call to retrieve, user information. So I'm just, subscribing to the events that the user microservice publishes. And then I get that event, and then I check if the property is driver. I get that information and save it in the database of the vehicle microservice itself. So that's just basically the idea here. What each service just does for ride microservice is the same idea. So when a ride request is created, we create information in the internal database of ride microservice and then publish the event ride created. Now that event, the vehicle microservice subscribes to that ride created, subscribes to the ride topic, and then captures that ride created event, and then takes that event and then checks if there are vehicles that are available. If there are vehicles available, it just assigns that driver to that particular ride request, and then it publishes back to the ride topic to say, yeah, vehicle assigned. And then notification, subscribes to almost all the events that are published, and then notification just takes that ride assigned thing and then publishes to, using the web push library essentially. So payment microservice, the same thing. This is where we'll create invoices, and so this produces event type of invoice created and payment received. So that's what this process is. Yeah, that's the high level architecture. So let's take a look at the code. All right, so here's the code. First of all, let's start with the Docker Compose file. So here's the Docker Compose file. In here, I have the Kong configuration. So services Kong, right? So I have the Kong configuration. And here, I'm setting Kong as database off. So I'm not using the database version of Kong. I'm just using so it's called DBless, right? So I'm using that version. You can see in here, I'm exposing this port. So this is the port that I'm exposing. So Kong is running on 8000, but in my host machine, if I'm connecting to this port, and so it's mapped to the internal container port of 8000. Now you can see the network I'm using, AppNet. So it's on the app network. And yeah, this is the admin endpoint. So I have this Conga admin port rather. So I have this Conga thing, right? The Conga, it's a UI that I configured. So with the Conga UI, you can see what's happening in Kong, right? Instead of just using the YAML file, you can just use the Conga thing to monitor what's happening. So for monitoring and observability, right, I've exposed the ports, right? So for example, if I go to port 1214, let me show you. Localhost 1214, you can see Conga, right? So this is what you can use this to monitor what's happening, what your API gateway, what Kong is doing, right? So that's that. So the reason why I can access it on localhost 1214 is because I configured it here, this port. If I remove this, then this Conga will only be accessible to containers that are running within this network because they're all on the same network. All right, so here are the microservices. So here you can see a user service, and I'm saying it depends on. So here's the database, Postgres user service database, and I'm using this hotel open telemetry collector service. So I'm using that for tracing, and then I'm saying it depends on Redpanda. So Redpanda is another service that for our Kafka thing, right? So that's user service, and then this is vehicle service, the same thing. Has its own Postgres vehicle service database. Write service, the same thing. Payment service, the same. Notification service, the same. Now, here's the Postgres user service. So this is the Postgres database for user service. It's running on the same AppNet, right? And the information, the user DB information, the password, and user sign-in information. So yeah, these are all the service databases. So yeah, so this is where we have, this is our observability. Now you can see in all of this, even the database and all of the services, I am not exposing the ports for it to be accessed from outside. But here in the Postgres admin container, I'm exposing this port here. You can see I'm doing this port 5050. So these are supposed to be like internal tools. They're not supposed to be tools that you expose to the public. They're like supposed to be internal tools. So if I go to Postgres 5050, I'll be able to see what is happening. Let me just go. Let me go there so you can see. Localhost 5050. So you can see I have my Postgres thing. In Postgres, the default email is admin, and the password is admin. So with this, you can have a GUI for the databases that are in the system. Right. So yeah, I'm signed in. So you can, let's say I want to see what is happening in the user database, right? So let's add user server. I'm just going to say user service. And then I'm going to set the connection. The host name is the name of the container. And then I'm going to set the admin, the username, Postgres user. And then the password is Postgres password. And there you go. We have our user service. And I'm going to connect to the database. So you see the user DB. And then you can open the schema and you see tables. And you see we have the user table here. So let's say I want to view all users, see the users in the system. There you go. So you have the users, you have John, you have Adam, a rider, driver, right? So yeah, so the reason I'm making this port, I'm exposing this port, the Postgres pgadmin, I'm exposing it is because you might want to, for internal tools, right? You want to be able to like see what's happening in your system. You can just access it. So here's the Redpanda thing. So Redpanda, this is the configuration for Redpanda. You can see it's not accessible from outside as well, but I have a UI, Redpanda console, that I can use to access, to see what's happening in Redpanda. So you can view all the topics and see all the events that are published. So let me show you 8080, that's what it's running on, Redpanda, localhost 8080, and there you go. So here's the console. So you can see all the topics here. I have write topic, I have user topic, I have vehicle topic. So let's see user topic. So this is the user topic. These are the two events that were published. So this is the event for user created for driver. You can see account driver. Now let me show you the consumer. So you can see vehicle service group is a consumer of whatever you post to this user topic. So vehicle service takes even notification as well. So when you create a user notification, subscribe to it and then sends a notification. So let me show you vehicle. So yeah, you remember when we added a vehicle for the driver? You can see the information here, Ford, Explorer, and all that. And then I think it's just notification that I subscribe to it. Then let's take a look at ride. Now see ride, I have notification, payment, ride, and then vehicle. Subscribe as consumer to this topic. And so here we have all the information. You have a payment received. So this was the source service was payment service. So payment service was the one that produced this particular event. So the event type was payment received event, right? So yeah, that's Redpanda console. All right, so yeah, so we have Prometheus. Prometheus is for capturing metrics within your application. We are all within services. I also have Grafana. So with Grafana, you can so these are for observability and monitoring for you to see what's happening in your system. And I have OpenTelemetry Collector. This is where you collect all the metrics and everything. And so for OpenTelemetry Collector, I'm using I'm using Prometheus, and it depends on Prometheus and Jaeger because it captures Prometheus metrics as well. And then I'm using Jaeger. Jaeger is the GUI thing that you can use to see so OpenTelemetry is for tracing, right? You can use it to see as request goes through your microservices. So you can, so let me show you Jaeger. So it's running on this. Let me show you Jaeger. Yeah, so here we go. So you can see, let's see, write service. See, it's not loading all the services. So you're supposed to be user service and vehicle service. So I think there's an issue on that end. I have to just verify. So, but here's write service. Let's see write service. You can see all the requests, all the things that happen on write service. I think it's only just giving me the Postgres connection. Oh, that's what it has here. Okay, let me see payment, if we have anything for payment. I want to see HTTP request. I'm not seeing the HTTP request. So I'll probably just check. I think there's something is broken. So it's not logging HTTP. So I wanted to, okay, so let me just use one of these, right? Let me see. No, this one, no, I wanted to like show you like a post request or any request that came in so you can use. So essentially this tracing thing, right? It will give you information that you can use for optimization. Let's say you want to like optimize you want to see how your service is performing. So you can see, for example, this took, you will see the time it took a particular call, API call, the time it took to return a response, and then that can inform your decision if you want to like maybe scale, or maybe a particular function is taking longer to return a response. That can inform you to like refactor and improve, the performance of that particular function. So I'll take a look at why other things are not coming out here. So that's Jaeger. And yeah, so that's basically the configuration, the Docker Compose configuration. Let me show you the services. So we have so now they are all on a single repo in production setting, right? Every microservice will have its own repo and its own CI/CD deployment, pipeline, right? But for this demo, everything is just on one repo. So you can see Nest.js application notification, you can see the user service Python thing, you can see the vehicle service .NET stuff in here. And then for monitoring, Prometheus, OpenTelemetry, the API gateway. So let me show you. So here's the conf.yaml file, and this is the configuration. So here in the services, right? So we have write service running on 4040, like internally in the application is running on port 4040 internally. And so when a request comes through the API gateway with this route, write, we are configuring it to map that particular request to the write service on port 4040. So this is the route configuration that it does. So for user service, it maps it to this. For vehicle service, it maps it to that. And so the reason it can call the service name directly is because they are within the same network, right? Right. So these are the plugins that I was talking about. So here you have JWT token, you have the cause, and you have rate limiting. So with cause, I'm saying origin. So this is the origin that is allowed, localhost 3000, which is the port where my Nest.js application, front-end application is running on that. So I'm just whitelisting it here. And then I have rate limiting. So I'm saying I can only allow 30 requests from any particular IP address in 1 minute. Only 30 requests is allowed from a particular IP address. And so in an hour, just 500. So this is where you set your rate limiting configuration. JWT. So in JWT, you must configure like a consumer. So this is the thing I'm doing. So you put in your public key. I got my public key from running this particular command here. I just got my public key there, and then I put it there and I run, because now I'm having to paste my keys inside the YAML file. And the reason for that is because I'm using, you can see, conf DB-less configuration. So I'm not using a DB. So if I was using the database, right, I won't have to paste all these things here. So if you just get the JWT related stuff from the database. All right, so that's all for the code review. Let's talk about the advantages of the microservice architecture. All right, so let's look at some of the pros of the microservice architecture. One is failure isolation, right? So because we have multiple services running together, if an issue occurs in any of the services, that issue is isolated to that particular service, unlike in a monolith application, where an issue can take down the whole application. So failure is isolated to the service that that has the issue. So with microservices, we essentially can mitigate the single point of failure issue. So if one service has an issue, it's just that service. It doesn't cascade to other services. So two, distributed team. So the microservice architecture shines well, works well when you have a distributed team. So you can have multiple people working on, different services. You can have different teams working on different services with different technologies. So the teams can take ownership of each service, of the service that they're working on, and then make decision on the technology that they want to use. The technologies that work, best for the features of each of the services that they're working on. So the third point is independent scaling. You can scale each microservice independently, so you can monitor performance, and then based on performance metrics, you can decide which service you need to scale. Then independent deployment. Because each microservice would ideally in a production setting be on its own repo, you can have its own, CI/CD deployment pipeline. And then you don't have to have any downtime with deploying your whole code base if you're on a monolith for just a minor code change, right? So you can deploy your individual services independently. Let's look at some of the cons. All right, so here are some of the cons of the microservice architecture. One, higher operational cost, right? Because you've broken up the application into smaller microservices, those services are going to be deployed on the server somewhere. And so that's more cost, more operational cost. And two, increased system complexity. So it can be complex to set up, because of the multi-components nature of the architecture. It can be complex to set up and to maintain. All right, so that's the video on event-driven microservice architecture. In the next video, I'm going to show you how to take this to production using AWS Elastic Kubernetes Service, and I'll be using Kubernetes to configure the application, and we'll deploy it to AWS Elastic Kubernetes Service. All right, so if you found value in this video, kindly like and subscribe to the channel, and I'll see you in the next video.